You're welcome to Maths Day edition of Taxonomy Online Mathematics. Today, 14th of September, happens to be the World International Day for Mathematics. So we want to use this day also to wish all viewers and mathematics lovers a nice day and take a simple question topic on set. Today we want to deal with set. No, we are saying that a set is any number that is of the form a positive or negative n root of a certain number, whereby the n is actually a number belonging to positive integers, excluding 0 and 1, which means n cannot be 0, it can be 1. The s is also a member of rational numbers, which means they are numbers that can be expressed as a fraction, a over b. So any number, but when they are placed under the root, if you cannot express them exactly as a fraction, then we call all of them become a set. Now, if I take a number of n to be 2, since 0 and 1 are not part, we have 2. So it means that the n become 2 root of a certain number, which I can say 3. Now, since n is beginning from this, we don't have 0 and 1. We know in mathematics 2 also stands for square. So this already is called a square root. So it cannot be square of a square root. So we have the 2 being eliminated. So this is a square root, which actually means that the n is 2. So this is square root of 3. The same way I can have a square root of 7. But if n assume a number of 3, it means that this is going to be, we know this is also called cube, a cube. So this is going to be a cube root of 4. So these numbers, so n can also be 4, 5, 6, 7. So we have 4th root, 5th root, 6th root, and so on and so forth. But under set, you only be concerned about the square root, even though we might come across some questions that have 4th root, cube root, and so on and so forth. But we only concern ourselves on set, which is square root. Now, from today, all we want to do today is talk about the concept of set, what we call similar set. Now, if I want to talk about a similar set, so two sets or any other set are said to be similar if they have the same radicand, meaning the same number under the root. So I can have root 7 and root 7 are similar. Now I can also have a mixed set. A mixed set simply means I have a rational number combined with irrational. You see, 7 is rational. So if I put 3 before 7, this is a mixed set. So this and also 4 root 7 is also similar. They are similar because we are only paying attention to the set. Since the set, the number under the set is called radicand. So the moment the radicands are the same, it means that these are similar sets. So sets that are similar have the same number under the root or the same radicand. That's a similar set. That's why we can easily operate them when we come into addition, subtraction. Alright. We also want to talk about some of the rules. As the rules engagement in multiplication. So if I have set A times set B multiplication, it means that the radicands are going to multiply together. So it become A times B, all under the root. But take note, if I have this root A plus root B, since A and B are different numbers, they are not similar. So I cannot say this become root of A plus B. No, this is not the same. It is only in multiplication that we multiply the radicals together. So if I have root of 3, root of 2, I can multiply this to become root of 3 times what? 2, which is what? root 6, I can say that. But if I have root 3 plus root 2, I cannot go forward and say that it is the same as 3 plus what? 2. No, it's not the same. So it is only in multiplication that we multiply the radicals together. That's the first aspect. And if I have if I have root A divided by root B, root A divided by root B, this also can be taken as a compound root A divided by B. It's vice versa. If I'll be given this, I can also say that this is the same as this. So if I have anything like root 6 divided by root 2, root 6 divided by root 2, I can rewrite this as a root of 6 over 2, which will give us root what? 3. That's another aspect of the multiplication. So if this is division anyway, if you are dividing the root over root, it becomes one complete root, with those numbers become a fraction of radicals under the root sign. Let's say we have root of A times root of A. We can say the radicals are the same. So we know that 2 times 2 is actually 2 exponent 2. So here I can still say that this becomes root A squared. Since under this we say we multiply the radicals together. So it's going to be A times A, that's A squared. And one property also says that if you have a root of a number squared, the answer is only the A. Because the root is also an exponent of half. Let's take this. I have root A squared. We are saying that the root as a sign, it has a value of exponent half. So if I want to remove the root, it becomes A exponent 2. I want to remove this root, therefore it becomes an exponent of half. So we know 2 times half is actually what? 1. So it becomes A exponent 1. So anytime I am multiplying a root under the root, which have the same number, 3 times 3, that's 3 exponent 2. 5 times 5. So if I have that, but don't forget, here can also be written as the root of A all squared. The root of A all squared. Because we are multiplying this by this. They are repeating. So root A repeating itself twice. So this could also produce the same answer as what? A. So if you are multiplying, they are the same. So for example, I have root 6 times root 6. This becomes the root of 6 all squared, or the root of 6 squared. And in all cases, this will produce an answer of what? 6. Because this is 36, and the root of 36 is what? 6. Alright, that is about some of the properties involved in that. Thank you.